In this video, we're going to be talking about trigonometry and the unit circle. This will be the introduction of how triangles fit into the unit circle in order to create the unit circle that allows us to memorize some of the important trigonometric values so easily. So the first thing we're going to do is we're going to start off with a xy coordinate plane. In that xy coordinate plane, we're going to go ahead and identify where the location for all the values of 1 on this system is. So those are all the locations of x is positive 1, y is positive 1, and so on and so forth. Then we're going to go ahead and connect all of those dots to the best of our ability with a circle. Now it's important to understand that this circle has a radius of length 1. In doing so, that creates what we call the unit circle. So that means that if I were to draw a point from here all the way out to here, that value right there is going to be the radius of the circle, and in this particular circle, r is going to be 1. Also, if I were to label this point as though it were a value on the xy coordinate plane, it's going to be a length of x here to that point right there, and then a length of y up to that point there. And therefore, that point right there would be labeled as x comma y in regards to this unit circle. So if r is 1 and we have x and y as a value on that location, this right here we can label as our theta. Keep in mind that every triangle that we build in the unit circle, its angle is in the central location of the circle. So if I were to build a triangle over here instead, the same thing's going to happen, except for my triangle is going to look something like this, where this is my central angle. And again, notice that this will be an x value here and a y value here. So we can do this for any given triangle such that we pick any specific theta such that it starts here and it goes to that location. Now this is comparative to that of a reference angle for an angle that happens to be longer than that situation. But in any case, some things we can definitely clearly state about the unit circle and the information with a radius of 1 is that every single triangle has that a squared plus b squared equals c squared, or more appropriately, the leg squared plus the leg squared equals the radius squared, or the hypotenuse squared. That Pythagorean identity theorem can be shifted into, in this case, x squared plus y squared equals to r squared. And for the unit circle, that means that x squared plus y squared equals to 1. So this is going to be almost always true in regards to the way that we situate the information on this unit circle. Now let's talk about the trig functions in regards to this circle. If I were to talk about theta, and specifically any trig function in regards to theta, sine of theta is going to be equal to, well, the sine is the opposite value over the hypotenuse, so y over r. Now this is for a generic circle, but if we're talking about a unit circle, it's simply going to be y over 1. But y over 1 is then just y. Again, this is going to be a generic circle, this is going to be a unit circle. This is the one that's generally more important, but occasionally this one's going to matter. So then we're looking at cosine of theta. The cosine of theta is going to be the adjacent. So from here, again, this is opposite. This over here is the hypotenuse because this is a 90-degree angle. This one down here is your adjacent. So I'm going to have x over r for a generic circle, and then for the unit circle, the cosine of theta is really just the x value. Then we have the tangent of theta, which you might recall as being opposite over adjacent, so in this case y over x. There's another rule in terms of tangent that's important, and I'm going to label that right now, is that if you took sine and divided it by cosine, you would find that the sine of theta over the cosine of theta is also equal to y over x, and therefore is the same thing as tangent. This is also true in the unit circle, so this rule doesn't necessarily change in any way. You'll notice that if I take the sine of the unit circle, y, and the cosine of the unit circle, x, and I divide them by each other, I get the same value. Then we can look at the reciprocal values, and the reciprocal values behave more or less the same way as they would in a triangle, which means that in the basic circle, it'd be r over y. In the unit circle, it'd be 1 over y. Secant, the reciprocal of cosine, would end up being r over x or 1 over x. Again, concept is all you're doing is you're flipping those two values. In terms of tangent, reciprocal of tangent is cotangent of theta. Cotangent of theta is going to be x over y, and this is true for both the generic radius circled as well as the unit circle. So this is the set of trig functions in respect to unit circles as well as any generic circle. So that means if we were to play with a specific type of circle, for instance, if we have a location on a circle such that it has a coordinate point of radical 3 over 2, comma 1/2, if that's the point we're working with, we can go ahead and draw ourselves a radius of that location, drop down a perpendicular, identify that there's a triangle there, and we'll notice that the x value is going to be radical 3 over 2 as well as the y value is going to be 1/2. To identify the trigonometric values of theta in respect to this circle, all you're going to do is you're going to go sine of theta, and we're going to have to figure out what r is. Cosine of theta, tangent of theta, and so on and so forth. So if we're asked to find the 6 trigonometric functions based on this coordinate point, being that in a circle, we're going to have to figure out what r is. Well, r, remember, is going to be basically the same concept as x squared plus y squared equals to r squared. This is again true for any radius of r, and we just have to solve for that r value. So we're going to plug in radical 3 over 2 for my x value. I'm going to square that. We're going to plug in 1/2 for my y value. We're going to square that. You'll notice over here that that's going to be 3 over 4 plus this is going to be 1 over 4, and therefore we're going to have 4 over 4, and sure enough, this is just a value in the unit circle because r is squared. R is going to be plus or minus 1, but because the radius will always be considered a length, we're going to view this value as always positive. That is not going to be the case for the x and the y, mainly because for most values in terms of x and y in a coordinate system, we do have negative concepts of negative x or of x values as well as negative concepts of y values. But we don't have a negative value conceptually for radius. There is ways to visualize it that way, but in most cases our r value will always be the positive case when we're going to solve and we end up with two possible values, one positive, one negative. You assume it's going to be the negative case or the positive case almost every time. So for the sine function on this, all we're going to do is we're going to go ahead and utilize the unit circle cases because we know that this is in a unit circle, which means that the sine is the y coordinate. The sine will always be the y coordinate, and therefore it's 1/2. So what I'm going to do right here is I'm going to set this equal to, and I'm going to write in here that my cosine of theta is x and my sine of theta is y. This is only true in the unit circle. Again, it changes slightly if we're working with a different circle such that we have to have a radius value that's not 1. So my cosine value then is going to be radical 3 over 2. My tangent is going to be sine divided by cosine. That's the way that I'm going to remember it. So it's going to be 1/2 divided by radical 3 over 2. Now this is not a nice valid number to work with, but what I'm going to do is I'm going to write it this way and notice that if I were to change these fractions, I'm going to get equal to 1 over the square root of 3, which is really just radical 3 over 3 when simplified. I'll then go ahead and go through the other 3 trig functions in terms of their reciprocals. That'll be the cosecant of theta, that's the reciprocal of sine, just being 2. I'm going to go ahead and find the secant of theta, that's going to be the reciprocal of this one, which is going to be 2 divided by the square root of 3, which is again not a valid answer. We have to always rationalize those denominators. So 2 square roots of 3 over 3. And then finally the cotangent of theta is going to be equal to the reciprocal of this value right here, which is simply radical 3 over 1. So that covers all 6 trig functions of a angle, given that that angle is defined by a single point on the unit circle or on any circle for that matter.